I'm going to start my lecture. Teka, may question pa ulit, no? Mock long exam. You'll be given, no, you'll be given a lot of exercises to do or to practice on your own. No? So dapat hindi problema yun. Okay, any other questions? Okay, so let's start today's session. Okay, so this week we're going to be taking up network theorems. This lecture I'm going to take up with you Thevenin's and Norton's equivalents. And then this might spill over to Thursday because the topic is rather long. And then on Thursday, we're also going to be taking up superposition. So those are three important theorems. No? Thevenin theorem, Norton's theorem, and superposition. This is not, again, no, I repeat, this is not the official, how do you say this, material that is being released at UVLE. I am giving you this lecture as supplementary material. Yung official material that is released at UVLE is being released or has been released by Dr. Ramos, who is in charge for this week. He already released the material. You can find it under, I think, supplementary files for the module on Thevenin and for the module on superposition. At the same time, he also recorded lectures for this particular module. So itong material na i-lecture ko sa inyo, this is just old material which I recycled from my previous classes. I'm going to post this also in UVLE, but like I said, again, this is not the official material for the course. No? This is supplementary material. Okay, before we take up Thevenin and Norton's theorem, I'd like to talk about source transformation. Okay. We're talking about source transformation here, and we're still talking about equivalence. I want this circuit on the left to be equivalent to this circuit on the right. You remember the definition of equivalence? Ang ibig sabihin natin ng equivalence is kung may nakakabit dito, let's say meron tayong nakakabit dito, no? Let's say X, kinabit ko rin rito, X. Itong X na to, hindi niya malalaman kung ano yung nakakabit sa kanya. Kung ito yung nakakabit sa kanya, o kung ito yung nakakabit sa kanya. No? If the two circuits are equivalent. No? That is the meaning of equivalence. So what I want is, I want the circuit on the left and the circuit on the right to be equivalent. No? Now, under what conditions will the two be equivalent? Let's take a look at the circuit on the left. No? Let me apply KVL. Let me apply KVL here. Okay. Applying KVL, I'm going to get Vs, okay, is equal to I times R, that is the voltage across my resistor, okay, plus V. Okay. On the circuit on the right, I'm going to apply KCL here, KCL, to that particular node. And what is my KCL going to look like? My KCL, okay, I'm going to get I of S is equal to, okay, what is the current flowing through this resistance? The current flowing through that resistance is equal to V over R, okay, plus I. So this current is equal to this current plus this current. Okay, let me manipulate my KCL equation. No? Let me multiply both sides of the equation by R. No? I'm going to get R IS is equal to V plus IR. Okay, IRS is equal to V plus IR. Now, if the two circuits are to be equivalent, no, note that this and this are equal, and therefore this must be equal to this. No? Because the right side of the equation are the same, that means that the left side of the equation must be equal. In other words, V of S is equal to R times I of S. So if I had this and I wanted to convert it to this, okay, then what is my I of S? I of S is just equal to V of S over R. No? I of S is equal to V of S over R. On the other hand, if I had this and I wanted to convert it to this, what is V of S going to be? V of S is going to be I of S times R. Okay, what does this represent? No? This is a voltage source in series with a resistor. Now the resistor R, that can be an external resistor or that can be the internal resistance of a voltage source. No, a voltage source, if it is a non-ideal voltage source, has an internal resistance. Now, that is what models the drop in voltage as you increase the load. Same thing here. This can be an external resistor, or it could also be the internal resistance of the actual current source. Anyway, important thing is this are these two equations. Okay. There's a question. Is it coincidental that this is similar to Ohm's law? Um, it's not Ohm's law. No, it's not exactly Ohm's law. No, although the equation looks the same. Yeah. No. So maybe you can say it's coincidental. But remember, this is not Ohm's law. No, because Ohm's law is the voltage across an element in relation to the current through the element. No? For example, Ohm's law is the voltage across R in relation to the current through R. No? But this is, for example, this is not this is not the voltage across this resistor R. Okay? So be very careful when you apply Ohm's law, no? Because it's supposed to be the voltage across, okay, and the current through. Okay. How did we get V over R for the KCL? Yeah. Ano yung voltage dito, no? This voltage, okay, that voltage is also equal to this voltage. Therefore, this current going down is equal to this voltage V over R. Okay. Para mapabilis, ano, if you can tell me your questions using your own voice so that I don't have to read, I think that might be easier, and also so I don't have to repeat the question to all of the others. No, wag kayong mahiyang magsalita, no? If you have a question, you can just shout it out. I don't mind being interpreted. Did I answer the question? Sino bang nagtanong nun? Si Benjamin Pineda?
Yes, sir, you did. Thank you, sir.
Okay, okay. Okay? So again, no, while it looks like Ohm's law, remember that the voltage V of S is not the voltage across the resistor R. And the same thing here, no? The current I of S is not the current through the resistor R. Okay, it just looks like Ohm's law. Okay, so here's an example. Solve for the power associated with the 6-volt source. So I have a 6-volt source. Ano yung power na dinideliver nitong 6-volt source? No, let's assume that it's no. Let's not assume that it is delivering power. No, that's why the question is associated with the 6-volt source. So how do I get the power associated by the 6-volt source? I would have to compute for, okay, sorry. I would have to compute for this current. No, let me call this I of 6 volts. I would have to compute for that current. If I compute for that current, I multiply it by the voltage, I'm going to get the power. Okay. If you wanted to follow the, sige, no. Let's do something. Sundan natin yung passive sign convention so that we get the correct sign for the power, no. So let's follow the passive sign convention. Let's compute for this current. Let's compute for this current. I. Okay. So why did I compute for this current? Para pag nakita natin na positive, then the voltage is absorbing, no? Absorbing. Pag nakita natin na negative, then the voltage source is delivering. That's only so that we follow the passive sign convention. Okay, so what will be our strategy? I have to compute for this I. So what I want to do is I want to simplify the remainder of the circuit. I want to simplify the remainder of the circuit. Remember, that is one of the strategies that we employed, no, for simplifying circuit analysis. No, kung isa lang yung unknown natin, in this case, ito lang yung unknown natin. Why don't I simplify the rest of the circuit to make it easier for me to compute for I? Yung dating simplification method na natutunan natin, ano lang, no? Ano lang, pag walang power supply, pag walang sources. So pag wala nitong 40 volts, marunong tayo mag-simplify, no? Anong ginagawa natin? We get resistances in series, resistances in parallel, we get an equivalent resistance. Ngayon, ang problema natin, meron na tayong voltage source. Okay, so are we able to simplify? Now that we know source transformation, we can simplify. So ano yung strategy na gagawin ko? Let me just outline the strategy that we will employ. No? Okay, so here I can convert this to a current source. No? I can convert to a current source. If I convert that to a current source, ano mangyayari, no? I'm going to get, so let me draw it down here, no? Let me draw it down here. I'm going to get a resistor in parallel with a current source this way. So now this resistor and this resistor will be in parallel, so that I can now get the parallel equivalent of this resistance and this resistance. No? And then I can convert it again to a voltage source. So dito, i-convert ko ulit to a voltage source. And so forth and so on. No? Yun ang gagawin ko. So let's see how that's done. No? So let's look at this. So here, I converted it to a current source. How did I convert it to a current source? Ang value ng current source ko is just 40 divided by 5. No? So itong 8 na to, this is 40 over 5. And then yung 5 ko, dito ko linalagay in parallel. Okay? Ngayon, itong 5 at saka itong 20 in parallel, this is equal to 4 ohms. That's equal to 4 ohms. I have a current source that is 8. Sorry. I have a current source that is 8 in parallel with a 4 ohm resistor. I can convert that now to a voltage source. My voltage source would be 8 multiplied by 4. So yun yung 32, no? This is 8 times 4. Ito yung 8, ito yung 4. And then ito ngayon yung 4 ohms ko. So voltage source na ngayon yan. Now what do you notice? You notice now that this 6 ohms, this 4 ohms, and this 10 ohms, those are all in series. So these are all in series. So this, and this, if I sum that, I'm going to get 20 ohms. The sum of all of that. So I'm going to convert this now again to a current source. So what is the value of the current source? The value of the current source is 32 divided by 20. So that's 32 divided by 20. And then itong 20 ohms ngayon nagiging in parallel. Okay, finally, your 20 and 30 are in parallel. So this is 12. And then I convert again to a voltage source, 32 over 20 multiplied by 12. That's going to give me 19.2. That is in series with the 12. That's finally in series with the 4. Finally, mako-compute ko yung IS. Right? How can I compute for IS? Well, this is just a simple KVL equation. This is a simple KVL equation. What's my KVL equation here? No, this is 6 is equal to IS times 4 plus IS times 12, okay, plus 19.2. So you can compute for IS. Okay, that's going to be 6 minus 19.2 over 4 plus 12. I'm going to get this. No? Okay, so notice here, our assumed direction is according to the path. It's not according to the sorry, no, this is not according to the passive sign convention. No, this is not according to the passive sign convention. It's according to the convention of the voltage source, no, that the voltage source is delivering power. I would have wanted the direction of current to be here, so that when you compute for the power, if it is positive, it is absorbing. If it is negative, it is delivering. But anyway, so what do we know about ice of S? The actual direction of ice of S is this way, and therefore this is absorbing. And the value is 0.825 multiplied by 6, which is 4.95 watts of power. No? So this is the actual direction. Actual direction. Any question with regard to this? So you can see how source conversion can simplify your life. This is successively converting from current source to voltage source to current source to voltage source until it becomes very easy now to compute for I sub S.
Sir, dun po sa
Go ahead, go ahead.
yung ano po, yung may voltage source po ba, pwede po bang i-treat yung as series po? Kasi may nag-short circuit na lang po dun sa 32 volts.
32 volts?
Sa second step po, dun sa...
No, ito?
Opo.
Anong question?
Series na po ba agad yun kahit po may voltage source na nakalagay dun sa...
Okay. Parang nalito ka, no? Kasi parang ito ba naka-series dito sa dalawang to?
Opo.
Yeah. Remember, there's only one current flowing here, ano? Isang current lang yung magfo-flow dito. Right? It doesn't matter what the arrangements. When you have components in series, it doesn't matter kung ano yung arrangement ng components na yon. Basta't isa lang yung dadaan na kuryente diyan eh, no? So pag meron kang circuit na ganito, kahit na ito ilipat mo ron pwede. And your KVL equation will still be the same. No? Try applying KVL here. Kahit na ipaglipat-lipat mo yung order ng mga resistor at saka ng voltage source, pareho pa rin yung magiging KVL equation mo.
Okay po, thank you
Nakikita mo
po.
ba yun?
Opo, gets po, thank you.
Yeah. Parang dito rin ano? I can change the arrangement ano? Yung isang resistor dito, pwede ko ilagay dito sa baba. Pag na-form ako ng KVL equation rito, it doesn't matter what the arrangement is, ano? It will always be the same. The KVL equation will always be the same. That means you can arrange, basta't naka-series, you can arrange the order. But I'm glad you asked that question, ano? Kasi yung iba parang hindi nakikita kaagad yun eh.
Thank you po, thank you.
Okay? Okay, I just want to mention these facts, ano? Kung meron kang resistor that is in parallel with a voltage source, okay? Kahit na anong value nitong resistor na to, hindi magbabago yung voltage between this point and this point, ano? It doesn't matter what the value of this resistance is. The voltage between this point and this point will always be equal to V sub S. Okay? So kung tatanggalin natin itong R's of P, the rest of the circuit will not be affected. Okay? So the circuit, if R's of P is removed, the circuit connected to A and B is not affected. Okay? That is because the voltage across R's of P, regardless of what R's of P is, will always be equal to V sub S. Now, ganito din dito, ano? Kung meron kang resistance dito, kahit na ano bang value nitong resistance na to, yung current na dadaan dito will always be I sub S. It doesn't matter what the value of this is. The current that will flow through here will always be I sub S. No? So if R sub S is shorted, kagaya ng ginawa natin dito sa circuit on the right, no? This has no effect on the rest of the circuit, no? On the rest of the circuit. It will have an effect on the power delivered by this. Itong R sub P will have an effect on the power delivered by this. But in terms of the circuit that is connected to A and B, it will not have an effect on the voltages and the currents and the power delivered. So in both cases, the resistances R sub P or R sub S can be removed. In this case, tatanggalin. In this case, is a short. No? Since they have no effect on the equivalent circuit that predicts the behavior with respect to terminals A and B. Okay, so why did I introduce this sort of ano lang, no? Insight. Why did I introduce this insight? Kasi pag meron kang circuit na ganito, okay, right away makikita mo na itong resistor na to, kahit natanggalin ko yan, hindi magbabago yung voltages and currents dito in the rest of the circuit. Kahit natanggalin ko itong resistor na to. And then itong resistor na to, kahit natanggalin ko rin to, hindi magbabago yung voltages and currents in the rest of the circuit. So if I gave you a circuit like this and I asked you, no, to solve for V sub O by simplifying the circuit using voltage transformation, ang magiging step ko dyan is, okay, ito yung original circuit. Tanggalin ko yung 125 ohms, tanggalin ko yung 10 ohms. Nagiging mas simple ngayon yung circuit ko, no? It becomes this. Okay. Okay. This is what I want to solve for. I want to solve for V sub O. Remember that when you do circuit simplification, you should not eliminate the unknown that you want to solve for. In other words, I want to solve for this. Dapat yung terminals at which I am getting V sub O, dapat ipe-preserve ko. I have to preserve that. I cannot eliminate that. So I have to simplify the rest of the circuit with respect to those terminals. So what do I see? No? Pwede ko itong i-convert to a current source. And that's what I did here. No? What is the value of the current source? That's 250 divided by 25. So the value is 10. And then now this 25 becomes parallel to the current source. So this is now my equivalent circuit. No? Okay, and then you know that you can combine the 10 amperes and the 8 amperes into a single current source. Remember, yung sources in parallel natin, so that becomes 2 amperes. On the other hand, the 25, the 120 are all in parallel. The parallel combination is 10. No? Note that I can put this in parallel because I am still preserving the terminals across which V sub O is measured. Hindi nawawala yung terminals across which V sub O is measured. So okay lang na gawin kong parallel itong 20, itong 100, at saka itong 25. So finally, ito yung circuit ko. So ang dali ngayon kunin ng V sub O. No? V sub O is just 2 amperes multiplied by 10 ohms, which is 20 volts. So that's another example. Any question with regard to this example? So there's a question from John. No? Suppose VO yung... Okay. If V sub O is through the 125 ohm resistor, actually kung V sub O is through this, alam mo na yung value niyan, di ba? That's 250 volts. No? I hope you see that. Ano? So the question is, suppose VOO po yung tinatanong is through the is across, no, not through. So across the 125 ohm resistor, matatanggal ba natin yung 100 ohm? No. You cannot, no. You cannot remove 100 ohms. You can only remove, no. You can only remove resistors that are in parallel with ideal sources, ideal voltage source. No? Or you can only remove a resistor that is in series with an ideal current source. But you cannot, in this case, for example, you cannot remove this, no? That is not in parallel with any ideal voltage source. I hope I answered that question. No? Okay. Okay, so let's take up what I wanted to take up today, no? Thevenin's theorem. This is a very important theorem. Itong theorem na to, I guarantee you every semester of your triple E life, you're going to hear Thevenin's theorem. Just a while, no? There's another question. Okay, wala pala. Okay, so ano yung premise ng Thevenin's theorem? Let's say I have a big circuit and I can partition that into two. So, meron akong malaking circuit that I can divide into two. No? So, the two are network A and network B. No? Itong term na to, linear, don't worry about that too much yet now. No? Suffice it to say that lahat ng circuits na pinag-aralan natin so far are linear circuits. No? By definition, a linear circuit is a circuit containing linear sources and linear passive elements. No? A resistor is a linear passive element. It's not so important yet now that you know the exact definition of a linear circuit. No? But we will tell you when a circuit is nonlinear in the future. No? So you have a big circuit. You can partition this into two circuits, circuit A or network A and network B. And let's say the two are connected through a pair of terminals called X and Y. No? Itong network B, sometimes we can think of that as the load of network A. No? So parang network A is supplying energy and network B is the load, no? Itong word na to, load of network A. And then yung isang assumption natin is, kung meron tayong dependent sources dito, then they are controlled only by voltages and currents also inside here. Same thing here, no? If we have dependent sources inside here, then they are controlled by voltages and currents only inside here. In other words, wala akong dependent source dito na nandito yung ano, no? Na nandito yung voltage or current. Wala din akong dependent source dito na nandito yung voltage or current, no? Naintindihan niyo yung ibig sabihin nun? No? So ito bawal to, no? For example, meron akong IX dito, meron akong let's say KIX here. So bawal 'yan, no? Kasi hindi pwedeng yung nagko-control nitong controlled current source na to dito nang gagaling. Hindi pwede 'yon. That's what we mean by this statement, no? So ano sinasabi ng Thevenin's theorem? Itong network A, I can replace this with a voltage source, VTH, in series with a resistor, RTH. And this is called the Thevenin equivalent of network A. That's a very important concept, no? This might be a complex circuit, but this will have a simple equivalent, and that simple equivalent is just a voltage source in series with a resistor. So that if I redraw this whole thing, ito na lang yung makukuha ko. No? Ito na lang. This is my Thevenin equivalent, and then this is my load. Now, how do I get VTH? VTH is the open circuit voltage from terminal X to terminal Y with the load removed or with network B removed. Nakikita naman niyo yun, ano? Kung tatanggalin ko to, ano magiging value ng voltage across X and Y? No? If I remove network B, what is the value of the voltage across X and Y? No? First of all, if I remove network B, there's going to be no current flowing. Walang current, no? And therefore, there's going to be no voltage drop across my resistance, and therefore VXY will just be VTH. No? So VTH is the open circuit voltage from terminal X to terminal Y with network B removed. Now, if network A, no? So this is a caveat. If network A contains only independent sources, so ano yung network A natin? Ito, no? If this contains only independent sources, then RTH is the equivalent resistance looking into terminals X and Y of network A with all independent sources reduced to 0. No? So tatanggalin ko itong network B. I'm going to look into terminals X and Y, and I'm going to get the equivalent resistance with all independent sources reduced to 0. Okay, with all independent sources reduced to 0. Okay, and that is what will be my RTH or my Thevenin resistance. Okay. Okay. It's not explained here, no, but great. How do you reduce sources to 0? We also call this we also say suppressing the source, no? Suppressing the source. That's the same thing. No? Reducing a source to zero, same as suppressing the source. If it is a voltage source, you replace with a short circuit. If it is a current source, you replace with an open circuit. That is how you reduce a source to zero. So if it's a voltage source, you replace with a short circuit. If it is current source, you replace with an open circuit. That is Thevenin's equivalent. Now, Norton's equivalent is very similar. So ito, same conditions as before. No? I have a big circuit. I partition it into two circuits. Okay, where network B is considered my load. So this is my load. Okay, with respect to terminals XY, I can replace network A now with a current source I of n in parallel with the resistance R of n. And that is called my Norton equivalent of network A. So if I redraw this, this is what I'm going to get. Okay, I of n in parallel with R of n, and then this is my load. So having done that, it should now be much easier to compute for my load conditions, the conditions here, no? By simplifying network A. Now, what is I of n? I of n, this one, is the short circuit current from terminals X to terminal Y, from terminal X to terminal Y, with network B removed. No? And that's very easy to see. No? If I remove terminal B, and I short this, so this is X and Y, what is the current that will flow here? No? What is IXY? Ang mangyayari, lahat nitong current na to, dito na dadaan. Wala nang dadaan dito. Okay? Nothing will pass here anymore, no? All the current will now pass here. No? There's this rule that says that current will find the path of least resistance. But this is zero resistance. So all the current will pass there. Actually, you can compute that using current divider, right? So if this is I of n, okay, and I have two resistances in parallel, okay, let's say this is R of n, and IXY. What is the value of IXY? No? IXY is equal to I of n times R of n over R of n plus RXY. But RXY is equal to 0 because it's a short. Right? So this you're just going to get IXY is just equal to I of n. Okay. So all the current will flow here. And then RTH, Rn is actually the same as RTH. That's the equivalent resistance from terminal X to terminal Y looking into network A with all independent sources reduced to 0. That is if network A contains only independent sources. Okay. If I were looking at you in class, your faces would probably be blank. So anong practical application ito? No? Well, let's take an example first. Okay, determine the Thevenin equivalent circuit of the following circuit with respect to terminals A and B. No? So ang assumption dito is tinanggal na natin yung load. No? So the assumption here is the load already is removed. Has been removed. And I just want to get the Thevenin equivalent of this particular circuit. So what is VTH? The open circuit voltage between VAB is equal to VTH. So I get the voltage here that is equal to VTH. Now, how do I compute for the voltage here? Okay, the voltage here is equal to this voltage. No? Okay, VAB, let me call this VR3, no? VR3. VAB is equal to VR3 because there is no voltage drop across R2. Why is there no voltage drop across R2? Can anyone tell me? Bakit walang voltage drop across R2? Just shout it out, ano? Why is there no voltage drop across R2? Anyone? Anyone?
Because there's no current flowing, sir.
Yes, no? I said just shout it out. Nahihiya pa rin si John, ano? Because there's no current. Remember, this is open. If this is open, that means there is no current, and therefore there's no voltage drop here. And therefore, if I do a KVL here, okay, zero ito, and therefore itong VR3 will just be equal to VAB. But what is VR3? I can compute VR3 by voltage division. Dahil this is hanging, this is now hanging, these two look like they're in series. R1 and R3 end up effectively being in series because there is no current that is flowing here. No? Ano yung definition natin in series? Sabi natin, it's in series if there's nothing connected to the point of interconnection. Well, in effect, parang nothing is connected. No? Kahit na may nakakabit dito, parang walang nakakabit dahil walang current na nagpo-flow doon. No? So walang kuryente na lumalabas dun sa branch na yun. So by voltage division, what is VR3? This is equal to VTH. This is just 30 multiplied by R3 over R1 plus R3. Okay? Since R3 and R1 are equal, anong VTH? Remember voltage division? Itong voltage na to will divide between this resistor and this resistor, okay, in proportion to the resistance values. No? So since R1 and R3 are equal, then VTH is just 15. No? Magi-split lang into 2. Okay? Now, how do I compute for RTH now? RTH now is the resistance looking into terminals A and B with my voltage sources, with my independent voltage sources suppressed. No? I only have an independent voltage source here, 30 volts. How do I suppress that? I suppress that by replacing it with a short circuit. Okay, so this is my suppressed voltage source. Naging short circuit. And then I have R1, which is 10K. And then I have R3, which is 10K. And then I have R2, which is also 10K. So A and B. What is RAB? What is RAB? If you take a look, RAB is this 10K in parallel with this 10K in series with another 10K. No? RAB is equal to 10 in parallel with 10K plus 10K. So what is this? This is just 15K. You have two resistors, equal resistances in parallel, so that's 5K. In series with 10K is 15K. So finally, what is my equivalent circuit? This entire thing, okay, is now just equivalent to, I have a 15-volt source in series with a 15K. So ito yung sagot ko. 15 volt, no? This is my Thevenin equivalent. That is my Thevenin equivalent. In other words, let's say ito yung nakabit, no? It doesn't matter that whether this is connected or this is connected, my load will not know the difference. So I can replace the original circuit with my Thevenin equivalent. Okay, so what about Norton equivalent? So same circuit, no? Same circuit. Itong circuit na to. This time I want to get the Norton equivalent. Okay, so what's the first thing I have to do? Again, no? Ang assumption dito, tinanggal na yung load. So first thing I do is, okay, there's a question here. I'll get to that. Ano? Very good insight, Mr. Ancheta. Can we use source transformation? Actually, yes, no? You can, no? But just for the sake of, sabihin natin, hindi natin kinompute yung Thevenin equivalent. Sabihin natin the question is, what is the Norton equivalent? How would you have computed for the Norton equivalent? No? So first, I short this, and then I get IAB, the current IAEB that will flow, which is actually equal to I sub n. Okay, how do I get IAB? Okay, how do I get the value of IAB? Well, you have many ways of doing that. Kung gagamitan nyo ng nodal analysis, okay, kung gagamitan nyo ng nodal analysis, what you would want to do is get the value of, let's say, Vx here. No? So what is your equation going to be? You're going to have Vx minus 30 over 10K. Okay, that's this current. Okay, and then plus Vx over 10K. That's this current. Okay, plus another Vx over 10K. That's this current. Okay, is equal to 0. So solve for Vx, and then IAB is equal to Vx over 10K. No? Because Vx is also the voltage across this. So the current flowing here will be Vx over 10K. So that's one way of doing it. Now, what are the other ways of doing it? You could also have done, convert this to a current source. No, I could have done that. After converting that to a current source, put these two in parallel, convert it to a voltage source, and then after converting to a voltage source, I just do 1 kVL equation. So you can also do that. So madami na kayong dapat na techniques na alam, no? Kung paano i-solve yung IAB. Anyway, you're going to get IAB, or which is equal to IN, okay, is equal to 2 amperes. Tama ba? Sorry, 1 ampere, 1 ampere. You're going to get 1 ampere. Okay. Yeah, that's right. It's 1 ampere, no? And then ano yung magiging Rn, no? Rn is just RTH that we already solved before, no? Which is equal to 15K. So finally, what is my Norton equivalent? My Norton equivalent is I have a 1 ampere source here. I have a 15K. And then this is A and B. No, that is my Norton equivalent. So what I'm saying is this and this are the same, no? Of course, tanggalin mo yung short circuit, no? With respect to A and B, tanggalin mo yung short circuit. The top circuit and the bottom circuit are the same. So this is my answer. This is my Norton equivalent. So notice that, and this is the question of Mr. Ancheta earlier, if I do source transformation, I can actually convert from my Thevenin equivalent to my Norton equivalent. So if I already know this, no, my Norton equivalent, I can convert to this. What is the value of my voltage? The value of my voltage would just be my Norton current multiplied by my Norton resistance. On the other hand, if I have the left side, I want to convert to the right side, the value of my Norton current would be my Thevenin voltage divided by my Thevenin resistance. Okay. Question from Mr. Calvin. 10 over saan yun, Calvin?
Sa IAB po, sir.
Yeah, no? This is 1 MA, sorry. Yeah, sorry. 1 MA. That's 1 MA. Sorry. That's right. No? Sorry. Tama ka. Thank you for catching that. No?
Galing po, sir.
Okay. So any question with respect to Thevenin and Norton equivalent? Okay, so circuit analysis using Thevenin equivalent. Okay. So this is just now the general procedure. Yung unang gagawin is tatanggalin natin yung load. Tanggalin yung load, which is network B. And then get the Thevenin equivalent of the remaining network with respect to the load terminals. So with in our previous perspective, yun yung network B. Yung network B yung load, tatanggalin natin yon. Tapos yung natitirang network, kukunin natin yung Thevenin equivalent. Tapos, ito na yan, ano? Pag nakuha na natin yung Thevenin equivalent, ibabalik natin yung load. Pag nabalik natin yung load, madali na natin makukompute kung anong gusto natin i-compute. So that's the context of using Thevenin equivalent. So it's really still part of circuit simplification. Remember, circuit simplification, we want to compute a particular value, so we simplify the remainder of the circuit. And we learn to do this when the circuit is resistive. Okay, so in this case, you can now do it. You can do circuit simplification even if the circuit has sources. Hindi ano no. So yung powers nyo medyo mas malakas na ngayon. Dati nakakapag-simplify lang kayo pag purely resistive. Ngayon, may sources, pwede na ninyong i-simplify. Okay, example. Use Thevenin's theorem to find Ix, the current through the 20 ohm resistor. Okay. Use Thevenin's theorem to find Ix, the current through the 20 ohm resistor. Ano ang gagawin kong strategy dito? The strategy I'm going to use is tatanggalin ko itong 20 ohms. Tatanggalin ko to. Okay, so that's what I do here. And then I get the Thevenin equivalent of the circuit with respect to itong points A, call this point A, and point B. No? So itong circuit na to natanggal natin yung load kasi yung load natin in effect was the 20 ohm resistor, no? That was our load. So I get the Thevenin equivalent with respect to the remaining circuit, no, without the load. And that will be just a voltage source in series with a Thevenin resistance. And then I reconnect the 20 ohm. I reconnect the 20 ohm. And then madali ko na masosolve kung ano yung gusto ko i-solve. Okay, how do I solve for VTH? It's easy to solve for VTH, no? All I have to do is do a KVL here. Right? I just do a KVL there. VTH is equal to, let's see. Let's do it step by step, ano? Para hindi kayo malito. So I'm going clockwise direction. No? My convention is from minus to plus is negative, plus to minus is positive. So I'm going to have minus Vx plus VTH. Okay. Minus to plus is negative, no? Minus Vy is equal to 0, or VTH is equal to Vx plus Vy. VTH is equal to Vx plus Vy. Now let's take a look. No? Ano yung value ng Vx? So remember, this is an open circuit. If that's an open circuit, that means this and this are in series. The 1 ohm and the 4 ohm are in series. So I can actually use voltage divider to compute for Vx. Vx is what? It's just 27 multiplied by 4 over 4 plus 1. If I do that, I don't have the answer here, no? This is 21.6 volts. Okay. What about Vy? Again, this is an open circuit. That's an open circuit. That means all the current in the 6 ampere source is just flowing through the 5 ohm resistor. No? Itong current na to, dito lang umiikot. So what is Vy? Vy is just equal to 6 multiplied by 5, no? Which is 30 volts. So finally, I get VTH is 21.6 plus 30, so that is 51.6 volts. VTH is 51.6 volts. 21.6 volts plus 30 volts. Okay, now how do I get RTH? How do I get RTH? No? RTH is the equivalent resistance looking inside terminals A and B with my sources suppressed. How do I suppress my voltage source? Replace it with a short. How do I suppress my current source? I replace it with an open. So to compute VTH, ano yung magiging itsura ng circuit ko, no? My circuit to compute VTH will be this. Ito yung suppressed voltage source, no? This is my voltage source na na-suppress. So this is 1 ohm. This is 4 ohms. This is A. Okay. This is B. This is 5 ohms. Ito ngayon magiging open circuit, no? So this is my suppressed current source. So looking into AB, ano yung RAB, no? Dito ako tumitingin. What is RAB? Which is RTH. That is just 1 in parallel with 4. No? Itong dalawa, nakaparallel itong dalawa. now in series with 5, no? Plus 5. So what is that, no? 1 in parallel with 4, that's product over the sum, that's 4/5 plus 5, no? 5 and 4/5 or 5.8. This is 5.8 ohms. Right? So finally, what is my Thevenin equivalent? Okay, I have 51.6 volts, 51.6 volts, 5.8 ohms. Yan ngayon yung A at saka B ko. Write something in the next page. Okay, actually, ito na yan, ano? Sorry. This is 5 times this 5.8 ohms. Okay, so this is now my Thevenin equivalent. Ang ginamit niya XY, no? Forgive the difference. I used AB. So what do I do now? I want to get the power. Remember the original problem? Ano yung original power? Current. No? I want to get the current through the 20 ohm resistor. So ibabalik ko lang yung 20 ohm dito. You put return, no? Return the load. And what is the current now? I is just equal to 51.6 over 5.8 plus 20. Which is equal to 2 amperes. Any questions? Any questions? Okay, what about circuit analysis using Norton equivalent? So ganun din, ano? Very similar. Remove the load, determine the Norton equivalent of the remaining network with respect to the load terminals, reconnect the load to the Norton equivalent circuit, and the desired quantity should now be easier to obtain. So let's just go through this bit quickly. Use Norton's theorem to find I sub x the current through the 20 ohm resistor. So same, no? This is the same problem. Same nga ba? Yeah, no? The same problem. So use Norton's to determine. So anong gagawin natin ngayon, no? So tatanggalin natin to. Tatanggalin natin yan. Now, how do I get now my Norton current? The terminals of the load I replace now. I short now with a short circuit. No, so this is my short circuit. Okay, so replace the 20 ohm resistor with a short circuit to find the resulting short circuit current, and this current now is my Norton current. Okay, how do I determine this current? No, right now the tool that you should already know very well is nodal analysis. So this is your nodal analysis equation. So what is this? This is just to compute for V sub A. No, this is only to compute for V sub A. So remember that this is just one node. This is just one node. So kalimutan muna natin yung current na to. Just to compute for V sub A, your V sub A minus 27 over 1 plus V sub A over 4 plus V sub A over 5 plus 6 is equal to 0. Dapat sanay na kayo dyan. So makukuha nyo yung V sub A ngayon. Kung alam nyo yung V sub A, right? If you know V sub A, then you can get this current. What is this current? This current is 27 minus V sub A over 1. And then I can also get this current. This current is V sub A over 4. So what is I sub n? I sub n is, let's call this I1, and let's call this I2. I sub n is just I1 plus I2. Okay. So I can get I1 and I2 because I know V sub A. So now that will enable me to get I sub n. No? So ito yung lalabas na value ng I sub n. And then yung RTH, sinolve na natin yan kanina, that's 5.8 ohms. Okay. So finally, this is your Norton equivalent. And if you check, if you do source conversion from the Thevenin to the Norton, you should get exactly that. So you put back the load, and then how do you get I sub y? You can get I sub x rather using voltage division, current division. So you can compute using current division. And you're going to get 2 amperes. Any questions? Any questions? Okay. Okay. Just some more, some more notes on RTH. No. At this point, up to this point, RTH has been determined by getting the equivalent resistance, looking into the terminals of the network with all independent sources reduced to 0. No? And I told you can do this. Let me go back to let me go back to okay. Let me go back here. No. Ito, no? Ito yung gusto kong sabihin. You can only do this. You can only do this under these conditions. If network A contains only independent sources. Pwede mong gamitin tong technique na to basta't yung network A, itong network A na to, ang linalaman nito puro independent sources lang. No? So again, we go back. That's what I was saying. Here, no? That's what I was saying here. Up to this point, RTH has been determined by getting the equivalent resistance, looking into the terminals of the network with all independent sources reduced to 0, but this will only work if the network contains only independent sources. What if it contains dependent sources? No? So anyway, this is an example, no? And try this on your own, no? Sa bahay ninyo. So this is a circuit with independent sources only, and then the problem is to find V sub O. So try this as an exercise. So this is the same problem, this time using Norton's theorem. No? Try this as an exercise. Now, what if the network A, we're talking about network A, contains both independent and dependent sources? Then yung pagkuha natin ng RTH, magiging iba na yung procedure natin dyan. Hindi na natin pwedeng gamitin yung procedure dati na basta't i-suppress natin yung mga independent sources, and then we get the equivalent resistance. Okay, I'm going to discuss that in Thursday's lecture. So that is the end of today's session. Are there any questions? Any questions? So this part of the course. This is where the course starts to get quite conceptual. Actually, so far, I think it still has been easy, but siguro nahalata na ninyo na as we go along, it's becoming more and more conceptual, ano? Nagiging pahirap yung mga concepts na ini-introduce sa inyo. That's why it's very important that you master the previous subject matter before moving to the next subject matter. Otherwise, may ipon yung hindi nyo naintindihan, ano? And then the only way for you to understand is by trying to solve the problems. So I encourage you to try to solve this problem and this problem, no? Just for you to experience using Thevenin's and Norton's equivalent. And then we're going to discuss this next time. Okay? So last chance for questions. If none, then I guess that's all for today. Okay? So thank you.
Thank you, sir.
You're welcome. You're welcome.
Thank you po, sir.
Yeah, you're welcome.
Thank you po, sir.